Okay, we're still looking at exercise 12.9 from Mathscape, Year 9 textbook. The first question is another bearings question. A park ranger, a park ranger flew his helicopter 76 kilometres east from C to D. So we're going to be going east from C to D. Which one's C? Where do I put C, on the left or on the right? From C to D, he's going east. So he's travelling this way. C is there, D is there, because if you go north, south, east, west, and you want to travel east, you're travelling across like that. From C to D, he's going due east. We okay with that? So we put 76 kilometres. And then, so from C to D, and then he flew 210 kilometres due south to E. So this one is 76 kilometres. This one is 210. It's not a bad idea to try and get it to some sort of scale. It doesn't have to be perfect, but the 210 should be at least double, or almost triple, the other one. But I shouldn't have drawn the 76 one so long. So C, D, good idea to put them on the outside too, the letters. C, D, and he's gone down to E. If you don't try and draw it to some sort of scale, it will look really bad later when you try and do the bearings. They just won't make sense. So we've got 76 and 210, and I'm going to join them. And the question is to find the bearing of E from C. So this is a right angle. So girls, this is question 7D. Travelling east from C to D for 76 kilometres, then travelling south 210 kilometres. And the question is, find the true bearing of E from C. So we're standing, where are we standing at? Where do you start from? C. Start from the from. C. We're starting from C, and I want to know the direction of E. The bearing of E, or the direction of E from C. So I need to put a north sign at C, and I'm trying to work out the direction of E from C. Pretend this is the clock. It's down here. Give me an estimate. What do you think that angle's going to be roughly? It's going to be between 90 and 180, isn't it? We're thinking maybe, I don't know, 150 or something. I don't know. But how am I going to work that angle out? Remember, we can use trigonometry inside triangles. So that's the bearing, but how am I going to work it out? So here's my triangle, 210, 76. I can't work out that whole thing using trig, but what can I work out using trigonometry? Angles in the triangle. Which angle would you find? This one or this one? The top one. Why do you think you'll find that? Because once you've found that, you're going to add 90 to it to get the bearing. So find the bearing of E from C. We know C's here, we know E's there. What's the direction of E from C? Starting at the from sign, bearings are measured from north clockwise. So I put a north sign at C and I go clockwise till I find the line that E is on. So I need that whole angle. But I know that here I've got 90 already, so if I just find that theta there, I can work out what theta is and then do 90 plus theta. Okay, in this triangle over here, I want these sides named. In relation to the theta, this 210 is what? And the 76 is? So which rule do we use? TOA. Tan theta is opposite over adjacent. Tan theta is 210 over 76. So therefore theta is tan to the minus 1 of 210 over 76. That's how you do it on your calculator. Tan of something is 210 over 76. Do you remember that, girls? So what do you get for the angle? Now, bearings are always whole numbers. We don't do degrees and minutes with bearings. To the nearest degree, please. So 3-figure bearings, there's no minutes or seconds. So what have you got? 70?
0.10
So it's 70 degrees. 70 degrees. So therefore the bearing, so part 1, the bearing of E from C is, what's the direction of E from C? Start from C, put a north sign, go clockwise till you find E. How do I do it? It is, but it's not exactly. I need to know it in, no, that bit in there is 70. So what's that whole angle? It's 90 plus 70, which is 160. Great. So that's the bearing of E from C. That's part 1, the bearing of E from C. In part 2, they want the bearing of C from E. Now, I don't know if you remember the videos you watched. There is a really quick trick with E from C and C from E. They're exactly, in other words, if you look from C and you're looking at E, it's there, like 160. There's a 180 degree difference between them always. Do you think you'd add or subtract 180 to the 160? If you subtract, you get negative 20. Your answer has to lie between 0. All right. So are you okay with bearing of C from C, of E from C? Now, part 2, I'll just show you and then I'll show you the trick. Part 2, bearing of C from E. What is the direction of C from E? So we start from E, put a north sign and go clockwise until we find C. That's the bearing down here. See, girls, because if I'm standing at E, remember, you've got to give me the position of C in a 360 degree circle. Well, if I start from north, I always have to start at north or 12 o'clock on the clock and go round till I find the direction that C is lying on. Girls, it's almost 360. What do you think that is going to be? All right, girls, if this is 70 here, remember that was 70? What's this in here? You know how theta's 70? Yeah, if that's 70 just in there, this is 20. See how I've got a north sign there and a north sign there? They're parallel lines. What is this angle in here? Alternate. Oh, why didn't I just do angle sum of a triangle? Okay, girls, just by angle sum of a triangle, if that's 70, this is 20. Got it? But girls, sometimes you can't do that. Okay? So girls, if I want the direction of C from E, I start from E, I put a north sign. Now, I know that's already north because E was south of D, and I go clockwise till I find C. So it's basically almost the whole circle except for this bit. If that's 70, then 70 plus 20 makes another 90. But often, sometimes the triangle isn't completed. And if you've got a north sign here and a north sign there, you can just do alternate angles. Okay, so what's the bearing of C from E? Isn't it 360 minus 20, which is 340? Now, look at 160 and 340. What's the difference between them? How many degrees? What's 340 minus 160? 180. I'm trying to give you the trick. When you work out the bearing of E from C and you get 160, let's say you can do that one, but you don't know how to do the other one. The difference is 180 degrees difference. You either add 180 or subtract 180 to that answer. If I subtract 180 from 160, I get negative 20. You can't get a negative. So you add 180 to it and you get 340. So if the bearing of E from C is 160, then the bearing of C from E is 340. It's 180 degrees different to that first one. How do you know whether to add or subtract? You do the one that lands you between 0 and 360. If I do 160 minus 180, I get negative 20. You don't do 180 minus 160 is 20. So direction of E from C is that, which is 160. Direction of C from E, start from C, put a north sign, go clockwise. That bearing is 340. I think we need to do a few of those. They're harder. Yeah. His new boat from the Marina M to a buoy B on a bearing of 243 degrees. So I'm going to start here in the middle of the page. North, south, east, west. He's travelling from M to B on a bearing of 243. Girls, just think you're starting at 12 o'clock and you need to go 243 degrees around. So start from north, go clockwise. How much have I done? 90, 180. Well, somewhere in here is 243 because it's between 180 and 270. So he's travelling in this direction. We don't know how far he's travelling. He then stops. He stops at B. He then changes, girls, as I was saying yesterday, every time a sailor changes direction, he needs to get his compass out again, find north, and set the new direction. So he's gone on one direction, and this direction is 243. He then stops. He then sails on a new bearing, so I need a new compass. I need a new north, all right? He then sails on a bearing of 333 degrees. So start here, put a new compass out. Where's north? Go clockwise, 90, 180, 270, 300 and something. He then goes 333 to a small wharf W, which happens to be due west of the marina. So I stop directly in line with the marina, like due west, because it tells me. So he goes on that direction of 333 degrees. I'm going to have to make this really big, okay, until he's exactly due west. Well, thank goodness it's due west, otherwise it'd be a nightmare to work this out. Now, I forgot to label this. This is the buoy here. That's the buoy, point B. Okay. Now, the distance all the way round there is 333. Now, they're asking you, and it's also 14 kilometres due west of M. So, you know, when he comes in this new direction, you think, when do I stop? Well, it's told you where to stop. It tells you that W is due west of M. Now, the first part of the question says, show that angle WBM is 90. So we need to find the size of this angle. And the way we're going to do it is with alternate angles. Sizes of angles in triangles, it's always alternate angles, always. Sometimes co-interior. All right, girls, if this is 243 all the way to there, what's that little bit there? I need to make this really big. Girls, look, 90, 180.
180 minus 243.
That's right. So I go 243 minus 180 is, I'll show you why. What's that? 243 minus 180. It's 63. So this angle in here is 63. So girls, watch. I'm just going to keep doing Z's. See this angle that I need to find here? It's made up of two bits, that bit and this bit, and I'm just going to work them out. So if that bit in there is 63, what's this bit here? The one that I've coloured in.
63.
Yeah. So that bit in there is 63. By alternate, can you see? All right. Are you okay that this bit in here, I'll show you. I'll show you. I've got this angle down the bottom like this. W, B. I've got, one sec. I've got WBM. Shh, girls. And I've got a north sign. I have to find the size of this angle and show that it's 90. What I'm trying to do, I'm going to find this bit, and I'm going to add them together. So the way I do it is that I do alternate. See how I've got a north sign and another north sign? Well, they're parallel lines. The two norths are parallel. There's only one north in the world, girls. And every north is parallel. So, alternate angles, if that bit in there is 63 in here, so's that bit in there. So that bit there is 63. Are you okay with that? By alternate. Now, girls, what's this little bit here? I know from north all the way around to there was 333. How do I work out that missing bit in here? 360 minus 333 is 27. So the little bit in here is 27. So that bit's 27. So in my working out, I go that angle W. So I show that. I show this down here because you're supposed to show. So I show that there. I show this here in my diagrams, and you make it nice and big, that that's 63 and that's 27. You show all this working, and you say angle WBM is therefore 63 plus 27, which is 90. Can I what? You know what I'm going to do? I'm going to move this up. You can just subtract, but you're not really showing me by subtracting, but it will work. Wait. Shh. Girls, this is the hardest type of thing that you would be asked. All right, I've got another page of this sort of stuff that we can practice. Draw what I've got again. That is meant to be a straight line. WBM, we just proved, was 90. We know that this is 14. Do we know any other angles in the triangle? Because to use trigonometry, guys, do I know this angle or this one? Can I work out this one? What's this in here? This one. Why don't I just do 270 minus 243? Or if that bit's 63, what's that bit? 90 minus, yeah, it's 27. So girls, this angle here is 27. You know, if that's 63, this one in here is 27. So now, girls, I've got a triangle. I've got a side length here, 14 kilometres. And I've got that this angle's 27 degrees. The question is to find the distance between the buoy B and the wharf W. So this one, D. Find the distance between B and W. There's my right angle. Why do you think, girls, they made us show that it's a 90-degree angle? Because you can only do trigonometry in right angle triangles. So if that angle down there wasn't 90, we wouldn't be able to use trigonometry or anything in it. Remember, SOHCAHTOA is only for right angle triangles. All right? So now the question is to find the length D. All right, girls, this is what we've got. Sine, cos, tan. Which one? Opposite, hypotenuse. Okay. Sine theta is opposite over hypotenuse. Do we know what the angle is? Sine of 27 is opposite, which is D. Hypotenuse is 14. Girls, can you see clearly that I can enter sine 27 on my calculator? This is not when you go shift sine to the minus 1. So D is what? How do I work it out? Sine 27 times 14, which is, etc., which is 3 significant figures. Can you just give me 2 decimal places? 3 numbers. 6.36 will do. Kilometres? 6.36 kilometres. This is question 9b. It says, so question 9b in the same exercise. While participating in an orienteering activity, that's just like bushwalking, a group of children walked from the starting position on a bearing of 212 degrees. Now, girls, there's my north sign. Where do you think they start from? Where do you think I start from? Where? Over here, in the middle, there. Where do I start from? Thank you. And I go 212 degrees. Where's that 212 degrees measured from? North, south, east, or west? And do I go clockwise or anti-clockwise? So that's where I start from. I go a little bit above it, and then I go 212 degrees. So how far have I gone so far? 90, 180, and a bit more. That whole thing's 212. Now, if that whole thing's 212, tell me what this little bit in here is. Good idea to work it out. Yeah, 212 minus 180, fantastic. So 212 minus 180 is 32. So that little bit in there is 32. It's always good to do this sort of stuff. I'm not saying you need it, but you might need it later. Guys, if 212 is all the way round, we always do our bearings from north to where they end up, and we put the whole angle there. That means that that whole thing's 212. So down here is the water hole, so I'm going to call this W. They then walked on a bearing of 302 degrees. Because I'm doing another bearing, I need to get my bearing. I need to know what direction I'm going in. What do I put? A. I get my compass out and I put a north sign again in here. And I start from north, I go clockwise. How far have I gone, do you think? 180, 270, 302. This makes sense. That looks good. So from W, I'm walking in that direction. If you look at that angle, it's like a reflex. So I'm going 90, 180, 270, 302 degrees. Now, do I have any distances? They then walked on a bearing of 302 degrees for 4 kilometres. Now they've called this a waterfall. So we had the water hole and the waterfall. I can't call them both W. What do we call one H and the other one F? I don't know. No, WH, water hole, waterfall. There you go. They're good. WH, no. WH, water hole, WF, waterfall. Which is 5.5 kilometres from the starting position. Where do I put the 5.5? WF to the beginning. Yep, to there is 5.5. Okay. Find the bearing of the waterfall from the starting position. Be guided. So instead of just asking that question, I'm going to change the question. Part 1, show that the angle. So show that, part 1, show that angle. Can I just call it FHS for start? FHS is 90 degrees. Show that this angle's 90. F for fall, H for hole, S for start. Okay? I can't call it. You can't give a 5 thing for angles. I've called this FHS. Show that that angle's 90. We're going to do exactly what we did in the last question. You know how this was 212 all the way? That bit's 32. You've got 2 north signs. As soon as you see north signs, start doing alternates, whichever way you can do them. Like that, like that. Here I can do alternate like this. Do you see? If that's 32, so's this. And then we also do, all right, we're almost all the way around the circle except for we do 360 minus 302. So I've got alternate, and then I also go 360 minus 302 is 58, and then I add them. And I know I'm off screen. So just one sec. That's 32. I need this angle. It's broken up into 2 parts. Find the 2 parts separately. 32 and 306 minus 302 is this little bit in here, which is 58. And so your working needs to be like that. So in your working, you would have this. 212 minus 180 is 32. 360 minus 302 is 58. And then you would go 32 plus 58 is 90. Got it? Now you draw the triangle again with the proper right angle in there so that you can actually do something with it. So I've got S, water hole, waterfall, 4 kilometres, that's a right angle, 5.5 kilometres, and they're asking for, and you can't see, and they're asking for the bearing of the waterfall from the starting position. Width, out, girls please. So show that that angle is 90. Part 2, I want the bearing of the waterfall from start. Bearing of the waterfall, which is F from S, the start position. Yep. It's an idea. If you show it on the diagram, I'm happy. Okay? Okay, now. Girls, which angle do you think you should find if I want an angle from the start position? F or the angle at S?
S.
Yeah. And it doesn't matter which one you find. Let's say you found F and you thought, why did I find that? How can you find out S really quickly afterwards? Angle sum of triangle. Yeah. So I'm going to call this theta, and we want to find theta. So let's find that angle first, because then we'll go back and we'll look at the bearing in a minute. So how do I find the angle? Sine, cos, or tan? Wait. We've got opposite and we've got hypotenuse. So sine theta is opposite over hypotenuse. I have to come back up to the diagram on the top. You know what I'm going to do? I need to get rid of this question now. I don't have enough room. I'll come back to the question in a minute. Sine theta is 4 over 5.5. Do I just press sine of something, or do I have to go shift sign?
Shift sign.
Sine to the minus 1 of 4 over 5.5. See, girls, 4 divided by 5.5, you can put the answer there if you want, but you don't have to. What do you get? Nearest degree?
47.
47 degrees. Once you've copied that down, we need to go back to the original diagram and put the 47 degrees in the original triangle. So girls, all we've done is worked out this angle theta in here, and it's 47. Am I allowed to move or not yet? Can I move back up? Stop! So up here, this angle's 47. The bearing of the waterfall from the start. Start from the start, go north and go clockwise until you find the waterfall. It's the 212 plus the 47. Can you see it? So I worked out that 47. I put it here because that's what I've worked out, that one. Because this is the 90-degree angle. That's it. No. I just want the distance from there around to there. From S to the waterfall. That's the angle. See, if it's like this, you're working out this angle. Does it make sense? Like there's the north sign where you started from, you're working out this angle. So the bearing is 212 plus 47, 259.